Okay, talking about an adiabatic process or any other process for that matter, what do we start with? What's the starting point? Well, the starting point is always the first law of thermodynamics, right? Which says that change in the total heat supplied, change in total heat supplied, heat is given by Q, not U, is given by the total change in internal energy plus the total amount of work that is being done on the system. Okay. Then we realize that du is nothing but CVDT, because the internal energy, how is it changing? It's changing by increasing the kinetic energy in the case of an ideal gas. Right now we're just talking about ideal gases. For a more complicated system, for a system which has interactions, for an ideal gas we don't assume any interactions between the two molecules, so there is no thing like a potential energy that we can talk about, or the motion, the total energy is only in the kinetic energy part. And hence, since kinetic energy is going up, we know that temperature is going up, and it's going up by a factor, a constant of proportionality, which we called specific heat. Okay. And dw was nothing but the work done, which was pdv. Correct. Now for an adiabatic case, what do you know? You know that dq is equal to 0, right? Since dq is equal to 0, what do you have? We have 0 is equal to cvdt plus p dv. Correct?
Yes, sir.
Yes, no, maybe.
Yes, yes, sir.
Okay, lovely. But that's not the only thing, right? You have other things. You have, first of all, when we say that du is just CVDT, you're already assuming an ideal gas. Since you're assuming an ideal gas, you can also assume the equation of state for an ideal gas, which is nothing but PV is equal to RT, correct?
Yes, sir.
So now what do we do? Any ideas?
So PdV plus VdP.
We can replace the t, right? We have, so here we have three variables. We have p, v, and t, and we have two equations. This is one equation and this is the other equation. So हम एक variable कम कर सकते हैं, so we can decrease one variable. What variable should we decrease? Well, you have a nicely arranged p dv here, you don't want to ruin that. Let's change dt. So how do you change dt? Well, just differentiate on both sides. What do you get? You get p dv plus VDP is equal to RDT. Correct?
Yes, sir.
So your DT is nothing but PDV plus VDP divided by R. So let's just put it inside. Let's see what happens. What happens is this becomes CV by R because of the R here in the denominator. DT becomes PDV plus VDP plus PDV. Okay.
Yes, yes.
Now dv term same, we can combine these two terms. So we can write this again as p cv divided by r plus 1 multiplied by dv plus cv divided by r multiplied by vdp, sorry. Correct.
Yes, sir.
Lovely. Now what?
Now, sir, next we took the LCM CR for the term CV by R plus
All you
1.
need to do is just uh, integrate on both sides, right? To essentially, so this is a differential equation at the end of the day, correct? So all you need to do is just solve the differential equation. So you started with a differential equation, which was the dq is equal to du plus dw. You simplified that differential equation using some and additional equations. How, where did you get that additional equation from? By assuming that we're working with an ideal gas. We got additional equations and then we went ahead and simplified the whole thing. Okay, so let's see what our equation is now. Our equation is 0 is equal to P. So there's a PdV and a VdP. So how about dividing the whole thing by PV, capital B and capital V? So what do you get? You get CV plus 1 divided by R. This becomes CV plus R and this becomes a dV divided by V plus another CV by R, which becomes a dP divided by IP. Correct?
Yes, sir, got it.
Lovely. So now what is your R? R is just Cp minus Cv, and gamma is Cp divided by Cv. So let's put it inside here and see what happens. What do you think will happen?
It will cancel.
It will cancel. Lovely. Everything cancels out. And what are we left with? We are left with the simple equation, which is dP divided by P plus gamma dV divided by V. And then we just integrate on both sides. And what we get, the solution of this equation is just PV to the power gamma is equal to constant. So essentially,
Sir,
you
thank
get
you, sir.
this by, again, starting from the first law, as you always do, assuming ideal gas, and you just solve the differential equation. What you get is this condition that PV to the power gamma is constant. Make sense?
Yes, sir, thank you, sir.
No problem. Okay, lovely. Okay, any other questions, Abhi tak? Nothing? If nothing, let's start. So today, mostly, okay. First of all, I would like to apologize. Sunday को नहीं मिल पाया. I got screwed over, lost my phone. बहुत ही अजीब था. So sorry about that. So to compensate for that, we'll do a lot of questions today, and we'll do only the first law, and we'll revise all of thermodynamics today. But before we do reach that, we have one topic that is remaining, which is a refrigerator, which is essentially, we have talked about the refrigerator before. We have talked about the refrigerator in the sense that if you have some working material here and there is a source here which is at temperature T1, and there is a sink here which is at temperature T2, and obviously T1 is greater than T2. So so essentially what you need to do in a refrigerator, आपको सिंक से टेम्परेचर निकालना है, जो ठंडा चीज है, जो फॉर एग्जांपल योर फ्रिज, you need to take out the temperature from the cold thing. How do you take out temperature from a cold thing? By doing work. So essentially you're doing work here in the heat engine. You this working material was doing work, as in आपका गाड़ी चला रही थी, आपका मोटर चला रहा था. लेकिन in a fridge you need to do work on the working material, and then जो remaining energy होगी वो source को चली जाएगी. So again Q1 Q2 and W, but it's essentially the same thing. Even if you look at the PV diagram of a refrigerator, it's essentially the same thing as a Carnot cycle. How did a Carnot cycle go? It went from A to B through an isothermal process, then from B to C in an adiabatic process, then from C to D again in an isothermal process, and then D to A in again an adiabatic process. Correct? So it went like this. So when it went like this, what was happening? You were pumping heat in Q1 through this AB process of isothermal, which essentially kept the temperature same, and all the energy, all the heat was converted into work done. Why was it converted into work done? Because dQ is just du plus dW, right? You're providing in heat Q1. Since this is an isothermal process, no, this is zero. Du is zero because du is just CVDT, and AB is an isothermal, so DT is zero. So du is zero, and so all the Q1 is just going into doing work, right? So AB में Q1 आया, and CD से it's essentially the same thing, but Q2 is going out, right? In a refrigerator, it's essentially the same thing, but the process is opposite. It's essentially the same thing, but the opposite process is happening. So essentially, what is happening? PV, you're starting from A, but now you're going to D. How you're going to D? You're going to D through an adiabatic process. Then you go to C through an isothermal process. Then you go to B through an adiabatic process again, and then you go to A. This should be lower than that, but you understand what I mean. Through an isothermal process. So it's essentially it's the same thing. Wait, my camera is not on. I just realized. Lol. Sorry, sorry, my camera was not on. So essentially, it's the same thing. It's the same process. It's the same Carnot cycle process, लेकिन उल्टा. So, and like in the Carnot cycle, you define something called the efficiency. You can also define the efficiency of the refrigerator. We'll call that in the Carnot cycle, we called it eta. In the refrigerator, we name it by another Greek letter, which is beta, and it's given by the heat you need to provide in. So essentially, here what is happening? Heat is being put in through the process D to C, and heat is being extracted through the process B to A. सो ये जो जा रहा है ऊपर इस सोर्स को जा रहा है और नीचे जो आ रहा है वो सिंक से आ रहा है इट्स एसेंशियली दिस प्रोसेस इस प्रोसेस में क्या हो रहा है वर्क डन हो रहा है सो इफ यू कैलकुलेट द वर्क डन इन दिस प्रोसेस इट विल एसेंशियली बी द नेगेटिव व्हाट यू गेट हियर राइट एंड वो नेगेटिव साइन जो होगा वो essentially is talking about work is being done on the system or by the system. In the adiabatic case, in the sorry, not in the Carnot cycle case, it was being done on the system. In the refrigerator case, it is being done by the system. Sorry, ulta. It was in the refrigerator case, it was done on the system. उसको heat extract करने के लिए, and in the Carnot cycle case, in the heat engine case, where you need to do work on a system, you sorry by the system. So this is by the system. So that's why there is a negative sign between the two work dones, which also indicates the arrow. Essentially कि arrow अंदर आ रहा है या arrow बाहर जा रहा है. उस वाले में arrow बाहर जा रहा था इसलिए negative sign था. इसमें arrow अंदर आ रहा है इसलिए ये positive sign उसका negative. So how do you define this? So this is again Q2 and this is again Q1. So how do you define this beta? It's given by the ratio of Q2 and the work done. It's opposite now. There eta was defined by work done divided by heat input. Here it's तुम कितना heat extract कर पाते हो from whatever you want to cool divided by the total amount of work you need to do to cool that substance, right? Again, in this cycle here on the top, the refrigerator cycle, we see that so Q1 is going out, work is being done. So what is Q2? What is Q2? कोई बता सकता है? Q2 is just Q1 minus W, right? This is coming in and this is going out. So arrow ये same है और ऊपर arrow है. It's like a vector. It's literally like adding like vectors. So ये ऊपर जा रहा है, ये arrow भी ऊपर है. So Q2 same sign. ये arrow अंदर आ रहा है तो minus sign. So Q2 is equal to Q1 minus W. So Q2 you can put it as Q1 minus W divided by W, which is just Q1 by W minus 1. And then you can go ahead and do the essentially the same process that we did in the Carnot cycle, which essentially showed us that Q1 divided by Q2 is just T1 by T2. इसमें हम जब A to B गए थे and B to C गए थे, C to D गए थे, पूरा कैलकुलेट किया था, उसका फाइनल रिजल्ट जो आया था हमारा was Q1 divided by Q2 is just T1 by T2. And so essentially what does your work done stay as? Okay, so your beta is essentially Q1. Okay, so Q2 is Q1 minus W. So W is just Q1 minus Q2. You put in the value of this in beta here. What do you get? You get Q2 divided by Q1 minus Q2, which is equal to 1 divided by Q1 by Q2 minus 1. From this equation 3, you can put in the value, you get 1 by T1 minus T2 minus 1. which is equal to T2 divided by T1 minus T2. So the essentially the efficiency in terms of the temperature कि अगर तुम temperature T2 जो भी दिया हुआ है 0 डिग्रीज दिया हुआ है कि जैसे फ्रिज में होता है तुम 0 डिग्री पे उसको सस्टेन करना चाहते हो so your T2 is 0 डिग्रीज Celsius so 273 degree Kelvin and T1 is essentially the surrounding so 24 degree Celsius or how many Kelvin that is and you divide the two and you get the efficiency of a refrigerator. Okay, lovely. Any questions up till now? लोगों को समझ आ रहा है?
सर सर आपने साइकिल उल्टी क्यों की?
हाँ?
दिस साइकिल आपने उसके एकदम कार्नोट की एकदम उल्टी बना दी ना दिस वन.
Yes, essentially it's the opposite of the Carnot cycle. It is exactly that. देखो तुमको सबसे efficient refrigerator चाहिए तो तुमको सबसे efficient heat engine लेके उसका opposite कर दोगे तो सबसे efficient refrigerator निकल जाएगा, right?
ओके ओके सर.
So it's essentially that logic only.
Sir,
That is, huh?
sir, beta is actually the efficiency of refrigerators, right?
Yes.
Beta. Okay.
Beta is the efficiency of the refrigerator and eta is the efficiency of the heat pump.
The efficiencies will be same, right?
Not really. I mean, not really. See, if you remember the efficiency of okay, let me clear all of this. If you remember the efficiency of a cycle which had the source here at temperature T1 and the sink here at temperature T2, um, and you have the working material here and this is so Q1 input किया Q2 बाहर निकला and उससे हमने कुछ work done किया. This was a Carnot cycle वाला तो essentially जो heat engine वाला पूरा cycle था वो ऐसे दिखता था. Here how did we define the efficiency? It was defined as work done divided by heat input. So this was essentially Q2 minus sorry Q1 minus Q2 divided by Q1. But beta, it first of all, it is defined for a different process. It's defined for an opposite process. So source you have here, you have sink here, and you have work done here. तो तुम heat extract कर रहे हो उसमें sink से Q2, Q1 and इसकी वजह से तुमको कुछ work done करना पड़ेगा system पे. So here, since it's essentially Q2 that matters more because essentially it is used for cooling things, right? So ज्यादा matter क्या
Yes.
करता है इसमें work done matter कर रहा है या फिर Q2 matter कर रहा है कितनी heat extract करो ये matter कर रहा है, right? So इसलिए
Yes, sir.
Q2 is at the top and W is at the bottom.
Okay, sir.
Make sense?
Yes, sir.
Lovely. Now let's do this thing. Let's go back and revise all of thermodynamics jaldi se quickly and then we'll do a lot of questions on this. Okay? अभी कोई सवाल है तो प्लीज पूछ सकते हो अभी पूछ सकते हो सब कुछ क्लियर है सबको वेरी नाइस find some good questions then. Yes. So, okay. Let's revise what all we did in thermodynamics. So where did we start in thermodynamics? We first defined whatever thermodynamics was. Then we defined thermodynamic system क्या होता है? With this diagram, thermodynamic systems. बाकी जो सब कुछ है, that is the surrounding, and जो system है वो system है. We defined certain variables जिससे हम ये system define कर सकते हैं, which was essentially okay. So how do you define a system? By three variables, PV and T. Correct. Then what did we do? I need some people to talk. Tell me हमने क्या क्या किया है अभी तक. Harshit, इसके so once we define the system, what do we do next?
Sir, please can you repeat?
See, once we've defined a system, so we are essentially reviewing all of thermodynamics, right?
Acha, from the very start, na?
या summary essentially we're reviewing all of thermodynamics. इस छोटी सी summary दे रहा हूँ, उसके बाद questions कर लेंगे. So first first of all in thermodynamics you need to define the system, and we've defined the system through three variables PV and T. Then what do we do?
Then we check, and then we see that the various ways in which energy can be supplied to the system and how does the system
No, no,
react.
no, no. But before that, so thermodynamics, we do something very, very important. We define something called equilibrium, right?
Yes, sir.
And from equilibrium, once we've defined equilibrium, we directly jump to the zeroth law of thermodynamics. Because that is what the zeroth law of thermodynamics is talking about. It's talking about equilibrium. And once we've defined equilibrium, we can actually essentially defining equilibrium means defining these three variables. See, एक सिस्टम का कुछ प्रेशर वॉल्यूम और टेम्परेचर हो सकता है, यस, बट सेइंग दैट एक सिस्टम का वॉल्यूम 100 डिग्री सेल्सियस है, that is a very different thing, because you're saying that it is consistently there and it's not changing. So that is why equilibrium is important. Okay, once we've defined zeroth law of thermodynamics, then what do we do? जल्दी
If A
बताओ
is
जल्दी.
in equilibrium with B and B is with C, so A and C are also in
Yes, yes, yes.
equilibrium.
That is essentially the zeroth law. That is essentially the zeroth law. What do we do after the zeroth law? We try to see how things evolve, right? एक बार हमने इक्विलिब्रियम में हमको पता चल गया चीजें कैसी हैं, उसके बाद ये जब चेंज करने लगेगा सिस्टम, फिर कैसे दिखेंगी चीजें. How do you do that? Well, you do that through the first law of thermodynamics. And essentially to do that, you need to talk about energy exchange, which is essentially in thermodynamics is in the form of heat. Thankfully, we know that. So we define Q, we define internal energy. We say that all the energy that I'm putting in is going into two places, U and work done. U is responsible for increasing temperature and work done is responsible for increasing volume or pressure. I mean pressure. If pressure increases, then it becomes interesting. But we can talk about that soon. But that's also in work done only. Okay, what next? Then to define processes, we need to first of all say that the process is slow. So if you want to go from A to B, you need to go slowly. तुम एकदम से उसका प्रेशर चेंज नहीं कर सकते बहुत ज्यादा ड्रास्टिकली, बिकॉज देन बीच में वो कभी इक्विलिब्रियम में नहीं रहेगा. अगर बीच में वो इक्विलिब्रियम में नहीं है तो हीट लॉस्ट होगी. तो हमारा फर्स्ट लॉ becomes not really very accurate in predicting exactly what happens. First of all, in a non-equilibrium system, you cannot even define the temperature. तो आप internal energy change define ही कैसे करोगे? So that becomes a problem. So that is why you need to slowly in equilibrium, ताकि हर point जो भी बीच में है, every single point is in equilibrium. We call such a process a quasi-static process, right? Then what did we do? We defined the rest of the processes. So there are three kinds of processes that are possible. Actually, four kinds of processes that are possible. पहला जिसमें टेम्परेचर कांस्टेंट रहे, आइसोथर्मल. जिसमें वॉल्यूम कांस्टेंट रहे, दैट इज आइसोबारिक, आइसोकोरिक. P constant, that is isobaric, and Q constant, that is adiabatic. Right? We did all of this initially. Then we went ahead and for each of these, we solved the first law and we got certain conditions. For an for a isothermal case, we got PV is equal to constant. For V, it's obviously that V is equal to constant. For P, we have P is equal to constant. And for Q, we have Q is equal to 0 or dq is equal to 0 or Q is constant, right? and we then studied how these essentially look. This If it's a small slope, it's an isothermal. If it's a large slope, it's adiabatic. If it's straight, because P is here, V is here, this is isobaric, and if it's straight down, this is isochoric. ये सब हमने डिफाइन किया. Then we defined another quantity. We defined some quantities, Cp, Cv. उनकी मदद से we defined gamma, and we defined R also. What else did we do? What is the next thing that we do? जल्दी बताओ क्वेश्चंस करने हैं. Abdullah, any idea what do we have to do next? Hello, am I audible? सुनाई दे रहा है
Yes,
हम
sir.
लोग को?
Yes, sir.
हाँ. So tell me what next?
Sir, engine?
Yes, absolutely. We defined what an engine is. Then we went on to the second law of thermodynamics,
Yes, sir.
which essentially says what? Thermodynamics. First of all, you cannot create an efficient engine, and second of all, you cannot create an efficient refrigerator. Those are the two statements, the Clausius statements, and the other statement. I forgot what it's called. Anywho, we calculated. We also calculated all the work done and everything in the first law. Second law. What else? What else? What else is there? The Kelvin Planck statement. Yes. We defined the Carnot cycle, which is essentially the most efficient cycle one can build. And using that, we built the refrigerator cycle, which is essentially the most efficient heat extracting thing we can get. Lovely. So that is all of thermodynamics that there is in your syllabus. Lovely. It's weird because I mean there is another topic of entropy, and we can obviously talk about that, but that is not there in your syllabus. So we can talk about it if you're interested at some point. Hmm. Let me see. What kind of a question do you want? Okay, all the assignments that I've been giving, have you guys solved those? Yes, no, maybe.
Sir, could you please repeat? आपकी आवाज बहुत हल्की आई.
मैंने कहा कि अगर जो मैंने असाइनमेंट्स आप लोग को भेजे हैं, क्या आप लोग ने सॉल्व किए? यस, नो, मे बी.
No, sir.
नो सर, कोई बात नहीं, कोई बात नहीं, अभी बैठ के करते हैं फिर 2-3 सवालों पे. दिस इज एक्चुअली an easy one, but sure, okay. So we have a PV diagram which looks like this. The triangle one we did, right? The triangle one we did in class. Lovely. Okay, so do this. Calculate the network done by a gas. First of all, by a gas, not on a gas. So I mean, positive sign, negative sign का ध्यान रखना. Whose thermodynamic behavior is represented by a right angled triangle ABC, where essentially A is 20, 6, B is 10, 12, and C is 10 comma 6. Um, yeah, you need to calculate the work done. प्रेशर का यूनिट्स है न्यूटन पर मीटर स्क्वायर एंड वॉल्यूम का यूनिट है मीटर क्यूब. So everything is an SI unit. Please go ahead. I'll give you like 5 minutes, 2 minutes actually. उससे ज़्यादा टाइम नहीं लगना चाहिए इसमें. 30 joules, lovely. यशवर्धन, could you tell us आपने कैसे किया ये?
Sir, area under
Area under the curve, lovely. So what are the points? Y axis यहाँ पे 6 मान लो, x axis यहाँ पे 10 मान लो, यहाँ पे 20 मान लो, यहाँ पे 12 मान लो. So essentially you go from, so 10 comma 6 is the smallest one, which is here. So this is point C. Then you have 20 comma 6, which is point A, and you have 10 comma 12, which is point B. Okay, so these are the 3 points. Now, which way is it going? Is it going towards the right or towards the left? I mean, clockwise or anti-clockwise? Harshvardhan, what did you take?
clockwise.
Clockwise, okay. Can you tell me why? कैसे पता चलेगा clockwise?
Work,
हाँ?
work done by a system is positive.
Yes, by the system means, so whenever you hear the word by the system, think about the Carnot cycle. Okay, the Carnot cycle goes clockwise, and Carnot cycle में by the system हो रहा है काम. So इसलिए कोई भी अगर कहीं भी बाय लिखा होगा तो वो हमेशा क्लॉकवाइज होगा, ऑन द सिस्टम होगा तो एंटी क्लॉकवाइज होगा, बिकॉज रिमेंबर रेफ्रिजरेटर इट्स द ऑपोजिट. ओके, so you just need to calculate the area under this triangle. Area of the triangle, well, you have the base which is 10, you have the height which is 6, and you divide by 2. What you get? 5 into 6, which is 30 joules. Okay, everyone? Yes, no, maybe.
Yes, sir.
Lovely. Okay, so let's move on to the next one. This is about the first law. So yeah, so you have, is it about the first law? We'll know soon. A metal of mass 1 kilogram. This is 1 kilogram at constant atmospheric pressure ATM, and at initial temperature as 20 degrees Celsius, is given a heat of 20,000 joules. Find A, delta T, so change in temperature, and B, work done, and C, change in internal energy. Go ahead. You're given some things also. You're given the specific heat, which is 400 joules per kg per degree Celsius. Note the units. Coefficient of cubical expansion, because you will need that. Cubical expansion के लिए gamma use करते थे, right? Is equal to 9 into 10 raised power minus 5 per degree Celsius. Density is given to be 9 into 10 raised power 3 kilogram per meter cube, and atmospheric pressure is essentially 10 raised power 5 Newton per meter square. All you need. This is all you need. Sure. No? Yes.
Sir, can you just read the question?
Okay. A metal of mass 1 kilogram. So you're given the mass at constant atmospheric pressure, which is given to be this, and at initial temperature, which is given to be 20 degrees Celsius, is given heat is given heat of 20,000 joules. इसका डेंसिटी आपको सारी चीजें दी हुई हैं, आपको चेंज इन टेम्परेचर निकालना है, आपको वर्क डन निकालना है, और चेंज इन इंटरनल एनर्जी निकालना है. दिस इज टेम्परेचर, दिस इज वर्क डन, दिस इज change in internal energy. क्वेश्चन समझ आया
Sir,
सबको?
mass is 1 kg or 11 kg?
1 1 1 1 1. A 50 degrees Celsius. Lovely. Lovely. Uh, okay. So, Casper, would you like to tell us how do you go about doing this? Svein? Yes.
Sir,
Yes, yes, yes.
the heat content is C delta T, so dividing it by C.
Yes. So, the heat is essentially mc delta T. C you're given, M you're given, delta T is what you need to find out, and delta Q is given. Just put in the numbers. So let's see. So you have 2 into 10 is per 4 divided by mass is 1. Heat capacity is 4 into 10 is per 2. Heat capacity is 4 into 10 is per 2. And delta T is delta T. This becomes 2. So 200 divided by 4, which is 100 divided by 2, which is just 50. So change in temperature is by 50 degrees Celsius. You can say that. So the temperature goes up to 70. Goes up to 70 degrees Celsius. Lovely. What about work done?
So I sent it to you.
Yes, tell me. Tell me. 5 into 10 is power minus 3. Love. Minus 3. Okay. Tell me. How did you go about doing this?
The pressure is given to be 10 to the power 5
एक सेकंड
and
एक सेकंड
change
जस्ट गिव मी
in
अ सेकंड
volume
जस्ट अ सेकंड एक सेकंड रुको हाँ नाउ टेल मी
Sir, initial volume तो मैंने
बच्चा मेरे को समझ नहीं आ रहा है क्या बोल रहे हो आप.
Sir, hello.
Yes.
Mass by density is equal to initial volume.
Yes, so initial volume is given by mass divided by density. Lovely.
So it is 1 by 9 times 10 to the power minus 3 cubic meter.
10 raised per 3
3 but is
ऊपर चला जाएगा या.
and
So, yeah, 1 by 9,000. Okay. तो change in volume कितना है?
change in volume 5 times 10 to minus 7.
How do you calculate that? Well, change in
The change in volume is equal to original volume times gamma times total temperature.
yes, times delta T. डेल्टा टी हमको ऑलरेडी पता है फर्स्ट पार्ट से, दैट इज 50. गामा हमें यहाँ पे दिया हुआ है 9 इंटू 10⁻⁵. वॉल्यूम हमने निकाल दिया है डिवाइड बाय 1 डिवाइड बाय 9 इंटू 10⁻³ एंड डेल्टा टी इज 50. सही कर रहा हूँ ना?
Yes,
Yes, sir.
sir.
The 9 cancels, so what do you get? You have 5 into 10⁻⁷ meter cubed. Correct?
Yes, sir.
Lovely. So work done कितना हुआ?
Work done 5
Till
times 10 to the power minus 3.
Well, that is P dV, P delta V. So you have,
Minus 2, sorry, sir.
yes, minus 2 into 5 into 10⁻⁷, which is 5 into 10⁻⁻² joules. 0.05. Lovely. That is work done. And what about change in internal energy?
20,000 minus यही.
Yes, absolutely. Very, very good. So हमने फर्स्ट लॉ को डायरेक्टली यूज कर सकते हो हम यहाँ पे. फर्स्ट लॉ क्या कहता है? पर डेल्टा क्यू इज इक्वल टू डेल्टा यू प्लस डेल्टा डब्ल्यू. डेल्टा क्यू हमको पता है, दिस इज 20,000. डेल्टा डब्ल्यू हमने निकाल दिया है अभी, विच इज 0.05. So your delta U is just 20,000 minus 0.05, which is 19,999.95 joules. So essentially, literally all of your heat is going into increasing the temperature and work done, क्योंकि it's a solid, right? First of all, it's a solid, so hence high density, and hence उसका उसका वॉल्यूम बढ़ाने के लिए आपको बहुत ज़्यादा एनर्जी देने की ज़रूरत है. तो इसलिए ज़्यादा से ज़्यादा जो हीट जा रही है वो उसका टेम्परेचर बढ़ाने में जा रही है. एंड दैट मेक्स सेंस ऑल्सो, राइट? यही होना चाहिए. इज दैट क्लियर टू एवरीवन?
Sir, can you repeat the second part?
सर आपने क्यों बोला कि ऐसा क्यों होना चाहिए?
बिकॉज इट्स अ सॉलिड, राइट? सो उसका वॉल्यूम इंक्रीज करने के लिए आपको जितनी एनर्जी देने की जरूरत होगी, क्योंकि वो बहुत टाइटली बाउंड है एक दूसरे से,
या
राइट?
सर.
दे आर वेरी क्लोज टू ईच अदर एंड दे आर वेरी वेरी टाइटली बाउंड. उसको उसका जगह बढ़ाने के लिए आपको बहुत ज्यादा हीट चाहिए होगी, because it's essentially first of all you need to change the state also, right? So you need to provide the L amount of heat, which is the latent heat. And but before that, even to just change temperature, change the volume, you need to put in a lot of heat. यहाँ से आपको सीधे सीधे कैलकुलेट करके पता चल रहा है कि कितना ज्यादा डिफरेंस है. देयर इज अ 7 ऑर्डर ऑफ मैग्नीट्यूड डिफरेंस. अगर मैं इसको एक एक मीटर क्यूब अगर मैं बढ़ाने की कोशिश करूं तो मुझे 7 ऑर्डर ऑफ मैग्नीट्यूड ज्यादा है उसको एनर्जी देनी पड़ेगी, which is a lot of energy.
Yes, sir.
Yes, lovely. Now,
Sir,
go ahead.
sir, in the previous question, can you explain the second part again?
The second part is work done, right?
Yes, can you explain it again?
Yes. So essentially आपको क्या क्या दिया हुआ था? आपको एक सेकंड, undo. Yes. आपको आपको उसका गामा दिया हुआ है. गामा इज essentially उसका क्यूबिकल एक्सपेंशन कैसे हो रहा है. अगर आपको याद होगा, हमने जब एक्सपेंशन के बारे में हम बात कर रहे थे तो हमने कहा था कि अगर हम इस एक चीज का टेम्परेचर बढ़ा देते हैं डेल्टा टी, तो उसका वॉल्यूम जो होना चाहिए दैट शुड बी प्रोपोर्शनल, इंक्रीज इन वॉल्यूम शुड बी प्रोपोर्शनल टू कितना वॉल्यूम था पहली बात वहां पे, और दूसरा कितना टेम्परेचर बढ़ा है. And the constant of proportionality we called it gamma. So this is gamma v delta t, right? Yes, no, maybe.
Yes, sir, got it.
लवली. तो फिर वॉल्यूम की इनिशियली जो वॉल्यूम था वो हमको पता है. कैसे पता है? हमको मास पता है, हमको डेंसिटी पता है, तो यानी कि हमको वॉल्यूम पता है, बिकॉज डेंसिटी इज जस्ट मास पर यूनिट वॉल्यूम, एंड हेंस वॉल्यूम इज जस्ट मास पर यूनिट डेंसिटी. यस, आप
Yes, sir.
वॉल्यूम की वैल्यू यहाँ से निकाल सकते हो. डेल्टा टी की वैल्यू आपने फर्स्ट पार्ट में निकाल दी है, गामा की वैल्यू आपको दे रखी है, तो यानी कि आप डेल्टा वी निकाल सकते हो. एक बार आपने डेल्टा वी निकाल दिया तो वर्क डन इज जस्ट पी टाइम्स डेल्टा टी, जहाँ पे प्रेशर की वैल्यू आपको ऑलरेडी दे रखी थी आपको, यानी कि दोनों चीजें पता है, आप दोनों को मल्टीप्लाई कर दो और आपके पास इसका आंसर आ जाएगा. 10⁵ -2 joules. Make sense?
Yes, sir.
Lovely. Okay, now do this question. Calculate the. Should I give this question? This is easy. Let it be. चलो कर लेते हैं, क्या फर्क पड़ता है. Calculate the change in internal energy when 5 grams of air, interesting, is heated from 0 to 4 degrees Celsius at constant volume. So volume is constant. और क्या देना है आपको? स्पेसिफिक हीट देनी है आपको ऑफ एयर. स्पेसिफिक हीट ऑफ एयर is given to be 0.172 calorie per gram per degree Celsius. So everything is in CGS units. Lovely. Go ahead.
सर वो स्पेसिफिक हीट ऑफ एयर है ना?
Yes, specific heat of air.
Sir,
Yes, please.
sir, send
I'm sorry. Can you repeat yourself? सुना नहीं दिया मेरे को.
nothing, sir.
Okay. 3.44 calories. Okay. What about in joules? Can you convert this into joules and tell me? और बाकी पार्टी क्या कर रही है?
सर हो गया बस.
Lovely. What about the rest of the party? Anubhav, Devanshi, Gaurav,
हो गया.
सबका हो गया? आमना. Okay. लवली. सो कोई बताओ मेरे को कैसे करना है, मेरे को नहीं पता कैसे करना है, बताओ मेरे को.
पहले डेल क्यू निकालेंगे.
एक मिनट, कौन बोलना चाह रहा है?
पहले डेल क्यू निकालेंगे एमसी डेल्टा सी से.
अच्छा जी, डेल्टा क्यू निकालेंगे. कैसे निकालेंगे? एम सी डेल्टा टी से. वेरी नाइस. एम क्या दिया हुआ है तुमको? 5 दिया हुआ है. सी तुमको क्या दिया हुआ है? 0.172. एंड डेल्टा टी कितना दिया हुआ है? 4. राइट. सो दिस इज 1.72 कैलोरीज. दिस इज डेल्टा क्यू. ओके, फिर क्या?
सर 1.72 क्या होगा? 5 into 4 20 है ना?
5 into 4 20. Absolutely. Yes. You're right. So it's twice of this. So this is 4. Let me just move this.
3.44.
3.42. Lovely. 3.42 calories. 3.42 calories is the total heat you input.
No,
But
3.44,
the
sir.
question is change in
Four
internal
four.
energy. Huh?
That is 3.44.
That is also 3.42.
No, no, I'm saying this is 3.
It should be
कहना क्या चाह रहे हो?
सर 172 का डबल 344 होता है ना.
344 होता है. ओके. हाँ, फिर क्या हुआ? What next? We need to calculate the internal energy. This is the total energy.
So
This
from
Yeah,
first law of thermodynamics work done is equal to 0.
Yes. So essentially, you have first law say delta Q is equal to delta U plus delta W, and since the volume is constant, this goes to zero. This implies delta Q is just delta U.
sir.
क्या?
But it is actually del PV, so वो P delta V plus V delta P होना चाहिए.
क्या होना चाहिए?
क्या कहते हैं del W का expansion actually P delta V plus V delta P होता है ना सर.
नहीं, it's just P delta V.
But then why when we integrated, जब आपने अभी थोड़ी देर पहले निकाला था एडियाबैटिक का, तभी तो दोनों वो हुआ
नहीं
था.
नहीं 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 नहीं, वो जो था उसमें मैंने dt की वैल्यू लिखी थी. dt is dependent on p dv plus v dp. Why? Because t is just equal to pv, right? rt. इसकी वजह से आया था वो.
मतलब यहाँ पे ऐसा कुछ नहीं होगा, यहाँ पे सिर्फ पीडी भी लेंगे.
Yes, that's it, pdv, because that is the work done. वर्क डन इज जस्ट pdv. उसके अलावा कुछ नहीं है. ये हमने प्रूफ किया, राइट? हमने प्रूफ किया था उसको, वो लेके गैस को लेके ना पिस्टन, कि वर्क डन इज जस्ट pdv.
यस सर.
ओके, लवली. Lovely. Clear to everyone? Yes, no, maybe? Okay, 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 okay.
Yes, sir.
चलो. हाँ, yes, go ahead, अब्दुल्ला. कुछ पूछना था
Yes.
आपको?
Clear, sir. Clear, sir.
पूछो पूछो. What happened?
नहीं सर कुछ नहीं पूछना.
Okay, lovely. So we can move on to the next question.
So 1 joule equals 4.18 calorie ना.
हाँ?
1 जूल 4.18 होता है ना कैलोरीज.
Yes, 1 joule is 4.18 calories. Yes, something like that. I don't exactly remember क्या था conversion, but यही था शायद. And इसको आप उसको multiply कर दो and you get the number of
या
joules.
या
Lovely. Calories में भी छोड़ सकते हो because question में सब कुछ calories में दिया हुआ था. Okay. Should I do the assignment question or should I do the other question? Good question. Lol. Okay, I'll do the assignment question. An ideal gas uh, has a specific heat at a constant pressure. Yes, pressure Cp, which is equal to 5 by 2 times R. Okay, the gas is kept in a closed vessel of volume 0.0083 meter cubed at a temperature of कितना है? 300 Kelvin. 300 Kelvin, okay. And pressure of 1.6 into 10 to the power 6 Newton per meter squared. An amount of 2.49 into 10 to the power 4 joules of heat is supplied to the gas calculate the final temperature and pressure of the gas. So what is happening? You are given the specific heat at constant pressure. The gas is kept in a closed vessel. उसका वॉल्यूम दे रखा है वेसल का, तो यानी कि गैस का वॉल्यूम दे रखा है एट अ टेम्परेचर, जो टेम्परेचर भी दे रखा है और प्रेशर भी दे रखा है. उसके बाद आप इतनी हीट सप्लाई कर रहे हो. What you need to do is calculate the final temperature and pressure of the gas. चलो, go ahead. This 14.3. Oh, okay, this was the previous question. Yes. क्वेश्चन सबको समझ आया?
Yes, sir.
Lovely. क्वेश्चन में कभी डाउट नहीं होना चाहिए. सॉल्यूशन में डाउट हो सकता है, क्वेश्चन में डाउट नहीं होना चाहिए.
सर
Yes, please go ahead.
सर यहाँ पे इन क्लोज्ड कंटेनर मतलब वॉल्यूम कांस्टेंट बता रहा है ना
एक मिनट फिर से बोलना जरा.
सर. गैस केप्ट इन क्लोज्ड वेसल का मतलब जैसे वॉल्यूम कांस्टेंट ले सकते हैं.
The volume is constant because वो वेसल के अंदर ही रह रहा है ना.
यस
उसके एस्केप तो कर नहीं रहा है, तो वॉल्यूम तो उतना ही रहेगा, राइट. अगर यहाँ पे कहीं लिखा होता है कि उसके अंदर छेद है वेसल के अंदर, तो फिर प्रॉब्लम अलग हो जाती है, which will also be an interesting problem to solve. But yes. Actually, that is a good question. Should be able to do that. The pressure will be different. सही बात. Even the final temperature can be different in that case. Temperature तो same ही रहना चाहिए यार. Okay, answers. किसी का भी नहीं आया क्या अभी तक? और
सर आप
1500 का है, इतना का है? Final temperature 83,107 Kelvin. Damn, that's a lot. 8.2 change in temperature tens per 4. Okay. Okay. Let's wait for 2 more minutes. बहुत बड़े बड़े नंबर आ रहे हैं तुम लोग के, ऐसा क्यों? Think about it again. Think about it again. What is happening here? You have an ideal gas जिसका specific heat दे रखा है आपको, उसका वॉल्यूम कांस्टेंट है, दिया हुआ है, उसका टेम्परेचर इतना है, उसका प्रेशर इतना है, जो दोनों चेंज होंगे, कुछ हीट सप्लाई की. इट्स द सेम क्वेश्चन एज बिफोर.
सर
क्या
ये
होता है? हाँ.
नथिंग नथिंग गॉट इट
ओके.
एक सेकंड सर बस एक सेकंड.
सी फर्स्ट ऑफ ऑल, ओके, गो अहेड.
सर ये फाइनल प्रेशर पूछ रहा है यहाँ पे, मतलब फाइनल
यस,
टेम्परेचर.
फाइनल प्रेशर और फाइनल टेम्परेचर दोनों. पहली बात, क्या आपको इसका मास पता है गैस का कितना है? Okay, so let's figure out what all is given here. Your CP or CV, yes, CP is given to be 5 by 2 R. Lovely. What else is given? Your volume is given to be 0.083 meter cube. इसको actually new page पे करते हैं. How do I clear all? Yes. Let's see. Let's start doing this. You're given CP to be 5 by 2 R. You're given the volume to be 0.0083 meter cubed, which is nothing but 8.3 into 10 is per minus 3 meter cubed. Correct? Lovely. सब कुछ scientific notation में लिखो, चीज़ आसान हो जाती हैं. Your temperature is, initial temperature is given to be 3 into 10 is per 2 Kelvin, and your initial pressure is given to be 1.6 into 10 is per 6 Newton per meter squared. Lovely. First question is to calculate the change in temperature. कुछ heat provide करो और change temperature हो रहा है. Makes sense. तो आप delta Q is equal to
सर
M.
heat is given.
हाँ?
Heat is given.
Yeah, the heat is given. Yes, the heat is given. Oh yes, the heat is also given. How much heat are you providing?
2.49 into 10 to the
9
power
into
4.
10 is per 4 joules. Lovely. Um, okay, so it's give. So delta Q is just,
Sir, it is MCP, I think.
no, it's CV. CV delta T
सर
because
लेकिन
of
सीवी
wall.
इंटरनल
Huh?
एनर्जी के लिए होता था ना.
हाँ,
CV तो इंटरनल एनर्जी के लिए होता था.
are you sure about that? Yes, I mean, CV इंटरनल एनर्जी के लिए होता है, ऐसे क्या मतलब है?
Yeah, because I memorized it the way कि U and V look similar. That is why.
That is actually a good way of remembering it. But is it true?
I'm mnemonic.
Go back to your notes, see if it's true. नोट्स में देखो आपने, खुद पता लगा. हम भी ढूंढते हैं, तुम भी ढूंढो. Okay, no, it is CV delta T from what I remember. Yeah. See, delta T, so essentially, जितना भी internal, what is it? CP delta T. यार मैं अभी भी confused हो रहा हूँ उसमें. हाँ. ये notes में क्या लिखा है तुम्हारे?
CP.
CP है. Are you sure? Okay, then this should be CP. But from what
ऐसा एक बार बाकी से कंफर्म कर लो. I'm not sure about my own notes.
Okay, should it be CP or CV? Everyone, tell me.
Sir, CP.
CP. Why is it CP?
Because in question it is said in the question it's specific heat at constant pressure.
Yes. But in the question, the volume is constant, right?
The data is given for the pressure constant.
But in the question, the pressure is changing, but the volume is constant, right? Is that happening or not? Or am I imagining it?
I will
Don't be afraid to talk to me. Just talk to me. Tell me. Come on, come on. No, it is CV delta T. Why is it CV delta T? It is CV delta T. Okay. Let's think about why is it CV delta T and not CP delta T. Okay. So if I put in some heat, okay, and I'm saying that it is going, it all of it is not all of it, as in if we want to increase the temperature, then my work done should be zero, right? So to keep my work done to be zero, my volume should be constant. So if dq has to be equal to du, then it should be cv del dt, right? Not cp dt. Because if it's cv, then we're talking about a thing which is at constant volume, and hence you can put this to be zero. That is why it's cv delta t and not cp delta t. अपना निमोनिक को उल्टा याद रखो. It is cv delta t.
मतलब U के साथ CP आएगा.
यू के था तो सी वी आएगा, राइट? ये यू वाला ही तो है, ये एग्जैक्टली वही है. सी डी क्यू हम यहाँ पे लिख रहे हैं, यस, बट व्हाट आर वी डिनोटिंग दिस डी क्यू बाय? ये जो हम कह रहे हैं, ये जो हीट है, ये इंटरनल एनर्जी में, दिस इज अबाउट इंटरनल एनर्जी, राइट? आप टेम्परेचर बढ़ा रहे हो, टेम्परेचर बढ़ा रहे हो यानी कि आप इंटरनल एनर्जी बढ़ा रहे हो, राइट? सो दिस डी क्यू इज एक्चुअली डी यू डेल्टा यू, अ हिडन डेल्टा यू.
Okay, okay.
डज दैट मेक सेंस?
Yes, sir.
Lovely. Okay, lovely. So what do you have? You have delta Q is equal to mCV delta T. Okay, हमको इसमें क्या क्या चीजें नहीं पता है. Well, इसमें काफी चीजें नहीं हमको नहीं पता
सर
है।
डेल्टा टी तो नहीं पता इसमें तो।
हमको क्यू डेल्टा क्यू पता है, सीवी पता है। सीवी एक्चुअली पता है नहीं पता है।
पता है सर, वो सीपी माइनस सीवी आर होता है ना।
सीपी माइनस सीवी इज आर, सो हमको सीवी भी पता है। बट डू यू नो एम?
Yes,
व्हाट इज एम?
sir, and we found through PV with NRT.
Oh, lovely. So PV is equal to nRT. ये initial case में, let's initially PV is equal to nRT, वहां से हम इसका नंबर ऑफ मोल्स निकाल सकते हो आराम से। लवली। सो प्रेशर कितना था हमारा? 1.6 इंटू 10⁶। वॉल्यूम कितना था? 8.3 इंटू 10⁻³ इज इक्वल टू n इंटू आर कितना होता है? 8.3 अप्रोक्सीमेटली, इंटू टी इनिशियल टेम्परेचर 3 इंटू 10⁻²। सही लिखा है? यस, नो, मे बी?
हाँ सर।
अरे यार बताया करो यार, गड़बड़ भी कर सकता हूँ, इंसान ही तो हूँ। 10, this is 10⁻³ so this becomes 3, this 2 cancels out and gives this 1, so it's 1/6 divide 1.6 divided by 3, uh, so this is 16/3, right? So your number of moles is just 16/3. So hence, your delta Q, which is 2.49 into 10 is per fourth, अगर हम इसको मोलर स्पेसिफिक हीट के समझ के करें rather than just specific heat, then we can change this n to m to n, right? Well, you can do that. 16/3 into the molar specific heat. You can consider this CV, CP to be molar specific pressure, specific heat at constant pressure. Into delta T. Delta T is something you need to calculate. CV कितना दिया हुआ था? एक second.
सर मेरे इसमें एक डाउट है।
Yes, please go ahead.
So because Q is equals to Q is also equal to MCV delta T and NCP delta T, so इससे तो M और N अगर इक्वेट करें तो मैग्नीट्यूड में इक्वल आएंगे ना।
Magnitude में क्या equal आएंगे?
N और M।
Not really, right? N is the number of moles. बट
बट
गैस का अपना अपनी मास पर यूनिट नंबर ऑफ मोल्स भी तो होगा, राइट? मतलब एयर का एक मोल में अलग मास होगा बनिस्बत के ऑक्सीजन के या फिर हाइड्रोजन के, मतलब सबका, क्योंकि सी व्हाट इज वन मोल टॉकिंग अबाउट? इट्स टॉकिंग अबाउट 6 into 10⁻23 मॉलिक्यूल्स और एटम्स, राइट? सो नंबर ऑफ मॉलिक्यूल्स सेम है, लेकिन अगर हर एक मॉलिक्यूल का मास डिफरेंट है तो फिर उस पूरे गैस का भी मास अलग होगा, राइट?
यस सर, बट हम यहाँ पे कुछ और चेंज भी तो नहीं कर रहे हैं, मतलब वी आर जस्ट चेंजिंग M and N and nothing else.
No, but why are we able to do that? We are able to do that because it doesn't matter, because Cp is independent of mass. तो आप इसमें तो जब हमने इसका मोलर स्पेसिफिक हीट और स्पेसिफिक हीट के बारे में पढ़ा था, तो हमने दोनों चीजें डिफाइन की थी। हमने स्पेसिफिक हीट भी डिफाइन की थी विच वाज बेस्ड ऑन मास, एंड मोलर स्पेसिफिक हीट भी डिफाइन की थी, विच इज एसेंशियली द सेम थिंग, बट एक कांस्टेंट का फर्क है दोनों में, राइट?
Yes sir, got it sir. Thank you sir.
लवली। सीवी कितना है? सीवी किसी ने अच्छी तरीके से बोला था, सीपी माइनस सीवी इज इक्वल टू आर। सो दिस implies सीवी इज सीपी माइनस आर, which is 5/2 r minus r, which is nothing but 3/2 r, correct? Just put in the value here. What do you get? You get 3/2 r, which is 8.3 into delta t. So एक कोई करो यार इसको, ये बहुत ज़्यादा है। 2 से ये गया 8, 3 से ये गया 3, what else do you have? You have 2.49 divided by 8 into 8.3 into 10 raised to power 4, which is delta t. Now whenever you're at this stage, just approximate things. 2.49 is just 2.5. 8 into 8.3, well, what is it? Let's just consider this to be 72, 72 or 64, 64 के बीच में आना चाहिए, and let's consider it to be 66. Okay, why not? So this is 2.5 divided by 66 into 10 is power 4. 3. So this is 25 plus 3. So multiplied by 4 divided by 4. What do you get? It's got 10 हो गया. So this is 10 square 5 divided by 66 into 4. This is 120, 240. So to consider this to be 250 approximately. So what do you get? 10 raised to power 5 upon 250 multiplied by 4 divided by 4. This becomes 1000 so about 400. About 400. Did you like how I calculated this?
Yes, sir.
Yes.
Because you can do that. You can actually do that. You can just approximate things. 2.49. Why do you want to consider 2.49, 2.1? Because you're 2.5. Why not? So this is just 400 Kelvin, and if you actually put in the numbers, you'll find it very close to this. It will be like 375 or something, but it won't be very different. So सबसे पास में जो आंसर है उसको मार्क कर दो. Lovely. So we found out the change in temperature, change in pressure. कैसे निकालोगे? Change in pressure कैसे निकालोगे?
P1 by T1 is equal to P2 by T2.
Oh, very nice, very nice. इसको डायरेक्टली फॉर्मूला भी याद होता है. Nice. So what do you have? You have constant volume. So PV is equal to RT. So because volume is constant, R is constant. This implies P1 divided by T1 is equal to P2 divided by T2. This implies P1 divided by P2 is equal to T1 divided by T2. Make sense? Yes, no, maybe?
Yes, sir.
लवली. सो T1 पता है, T2 पता है, वैल्यू डालो. P1 पता है, P1 ये है, T1 ये है, T2 आपको यहाँ से निकल सकते हैं. तो 300 से 400 चला गया तो वेरी गुड. T2 यहाँ से निकल जाएगा एंड P2 की वैल्यू you can find out by plugging in these three values, and what you get is 3.6 into 10 raised to power 6 Newton per meter square. Okay? ये आना चाहिए सबका.
Got it, sir.
क्वेश्चन सबको समझ आया क्लियरली? कोई डाउट नहीं है? We can move on to the next question.
Yes, sir.
Okay, lovely. Whiteboard. Yes. So let's move on to the next question. Okay, so now things are actually expanding. Lovely. Find the final volume of a gram molecule of gas after an isothermal expansion at 127 degrees Celsius. Okay. If the original volume was 4 into 10 raised to power 2 centimeter cubed, 4 into 10, yeah, 400 centimeter cubed, lovely. Full stop. Given the amount of work done by a gram molecule of a gas during its expansion is 2302.6 joules. Yeah, that is it. What else are you given? You're given R to be 8.3 joules per mole per Kelvin. Lovely. Go ahead. क्वेश्चन में कोई डाउट? कोई डाउट क्वेश्चन में?
सर अभी पढ़ ही रहा हूँ.
अच्छा, भी पढ़े रहो, वेरी नाइस. Find the final volume of a gas molecule of a gram molecule of gas after isothermal expansion at 127, 127 degrees Celsius. If the original volume was 400 centimeter squared, uh, given centimeter cubed, given the amount of work done by the gas molecule or by gram molecule of gas during its expansion is 2302.6.
Sir,
Yes.
sir, can we consider the gas to be ideal?
Can you consider the gas to be?
Ideal.
Yes, yes, yes. Obviously you can consider. जब तक नहीं दिया ना, अगर कोई specifically तुमको नहीं बोल रहा है कि this is a van der Waals gas or this is a specific gas, consider it to be ideal. Okay?
Yes.
Always do that, no matter what.
Sir,
Yes.
so this is isothermal, so del Q तो zero हो जाए, sorry del U तो
Del
zero हो
U तो
जाएगा.
zero हो जाएगा. Very good.
सर तो ये del Q equals del W आ जाएगा.
Yes.
बट देन या भाई यहाँ पे मेरी क्वेरी भी है सर, जैसे अभी आपने बताया था कि नो आपने बताया सर, मतलब द फॉर्मूला इज दैट NCV डेल्टा टी, इफ डेल्टा टी इज जीरो, सो वो पूरा टर्म क्यों जीरो नहीं हो जाएगा?
Yes, zero होगा.
आई मीन क्यू भी जीरो होगा.
नहीं, बट दैट Q इज इंटरनल एनर्जी ने, और तुमने जब इंटरनल एनर्जी को ऑलरेडी जीरो बोल दिया है तो ऑब्वियसली वो जीरो है. तो यानी कि सारा जो हीट जो हो रहा है वो सारा वर्क डन में जा रहा है, यानी कि वॉल्यूम एक्सपेंशन में जा रहा है.
ओके 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 सर, गॉट इट. सर यहाँ कोई स्पेसिफिक हीट नहीं रखी है?
स्पेसिफिक हीट की जरूरत है नहीं, स्पेसिफिक हीट की जरूरत नहीं है तुमको.
CP समथिंग.
Sir,
नहीं, जरूरत नहीं है.
sir,
यस यस, गो अहेड, गो अहेड.
is it nearly 6.8 times 10 to the power minus 4?
हैं?
No.
नहीं, इन सी, all you need to do, you are given the initial temperature, you given the initial volume, you are given the work done, तुमको फाइनल वॉल्यूम निकालना है, राइट? वर्क डन का तुम्हें ऑलरेडी पता है क्या होता है इन एन आइसोथर्मल केस, राइट? इट्स जस्ट व्हाट इज इट?
NRT log VT.
RT log V2 divided by V1. You just have to apply that formula, that is it.
Sir,
हम्म.
sir, अगर वैसा करेंगे तो नहीं होगा कि PV is equal to RT करके प्रेशर को वॉल्यूम निकाल दिया और P डेल्टा V करके.
Okay, let's
Sir,
let's do this quickly. इसका जल्दी से इसका सॉल्यूशन करते हैं. नहीं समझ आ रहा है, नहीं समझ आ रहा ना कैसे करना है, क्या आंसर आ रहा है?
सर 1 मिनट रुक जाओ सर प्लीज.
1 मिनट रुक जाओ यार, 1 मिनट है नहीं ना हमारे पास अभी. एक तो आई रियली लव दिस 127 डिग्री सेल्सियस टेम्परेचर. कुछ भी मतलब रैंडम नंबर. Okay, just 2 minutes left. I need to do this. So टेम्परेचर क्या दिया हुआ है आपको? 127 डिग्री सेल्सियस. इसको केल्विन में कन्वर्ट करो. So that's 273 plus 127, which is equal to 400 Kelvin. That is why I left 127, just 400 Kelvin. So simple to write. Volume is given to be 400 centimeter cubed, and work done is given to be 2302.6 joules. Correct? Given it's an isothermal process, your delta W is just P delta V, and P हमको पता है is nothing but RT divided by V, right? So which is equal to P multiply sorry P तो हो गया RT divided by V dV. Just integrate that from initial to final. What do you get? You get RT log
V2
V2 divided by V1. Correct?
yes sir.
So work done आपको दिया हुआ है. This is given to be what? 2302.6. R दिया हुआ है आपको 8.3. टेम्परेचर दिया हुआ है आपको 400. आपको ये log V2 by V1 निकालना है. Well, notice one thing here. 12. Okay. So what is 8.3 into 4? 4 3s are 12. Given the 16, 24 4s are given the 16, 32, 33. 33.4. So there is a 3,300. Okay, lovely. हाँ, ठीक है, ठीक है, ठीक है, ठीक है. Okay. So clear. No, not clear, not clear. Erase, yes. Let's remove the top part. Lovely. कोई बता सकते हैं इस लॉग का बेस क्या होगा?
10
लॉग का
नहीं
बेस.
sorry E
Yes,
E.
natural base. Lovely. So what do you get? You get
Sir,
2,300.
sir.
Yes.
इसको अगर 10 में कन्वर्ट करेंगे so it will be 2.303 which will cancel this 2302 something.
Very nice, very nice. So so this is just essentially what you're saying. Log base E is equal to just log base 10 into V2 by V1 divided by log E base 10, right? What is log E base 10? और log 10 base E अगर ऊपर ले जाना हो तो. ऐसे नहीं कर सकते ना. हाँ, ऐसे नहीं कर सकते. बताओ 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 बताओ.
सर लॉग्स नहीं आते उतने अच्छे से.
लॉग नहीं आते तो कैलकुलेटर किस लिए दिया है ऊपर वाले ने?
सर
हाँ.
सर क्या हम ऐसे नहीं छोड़ सकते कि 4 टाइम्स इंटू माइनस 4 ई टू द 0.7 बोल के ई के टर्म्स में.
क्या?
सर
Yes, yes. Okay, so
सर
see, wait. This V1 is given to be 400. Just put in the values. What you'll realize is that V2 is equal to
मेरा
what?
एक क्वेश्चन है where did this log E base 10 कहाँ से आया? It was
Oh, this is just log properties, right? Log की property होती है कि log A base B is nothing but log A divided by log B, right? बेस कुछ भी हो सकता है. बेस 10 ले लो, बेस ई ले लो, बेस कोई जो मन करे वो बेस ले सकते हैं आप. दिस इज अ प्रॉपर्टी ऑफ लॉग, राइट?
नहीं सर मैंने बोला था कि वो फॉर्मूला लगा सकते हैं कि दैट log E equals 2.303 log 10 सो आपने ये क्या किया मतलब?
ये कहाँ से आया पूरा?
नहीं या ना RHS कहाँ से आया?
आरएचएस कहाँ से आया? आरएचएस इज दिस, नो? लॉग बेस ई V2 बाय V1 को मैंने ये लिख दिया ऐसे, ये यूज करके. और यहाँ पे एक आरटी जो था, आरटी को मैं नीचे ले गया. ये आरटी हो गया आपका. ओके.
And where is that 2.303?
2.3 ये रहा, ऊपर ही तो है.
2.303
2.303 तो इसका इनवर्स आएगा ना. So essentially, what will happen is 1 by log e base 10 is 2.303.
Okay.
That is
I
why it is
think we
coming.
were we were we were made to learn that formula, and that is why.
Yes, you were made to learn that formula. यहाँ से आता है वो formula लेकिन.
Okay, sir.
Okay, now you know. चलो ठीक है. Once you put in, you'll get the value of V2 to be 800 centimeters cubed. So just check that and we'll meet each other tomorrow. क्योंकि अब late हो